Asteroid explosions, airbursts, and past impactors paint a grim future for our Earth. We're studying here Tunguska and the next Earth impact event. This is by Dan Mayes, University Today on phys.org. We have a lot of scars on Earth from past impacts. This is the Manicougan comet impact crater in Quebec, Canada. There's a lot of impact craters in Quebec and Canada if you want to see Google Earth concerning that. The recent meteor explosion over Chelyabinsk brought to the forefront a topic that worried astronomers for years, namely that an impactor from space could cause widespread human fatalities, of course. Now we know that Chelyabinsk meteor that came over was not seen. It was a surprise because it came from the direction of the sun, and the space telescopes cannot dip down that far to see what's coming from the direction of the sun. So that was a total surprise. Now, indeed, the 1,000+ injured recently in Russia from that was a wake-up call. Should humanity be worried about impactors? Well, yes. This is what astronomer Neil deGrasse Tyson said on CNN's F. Zachariah. He said the geological and biological records attest to the fact that some impactors have played a major role in altering the evolution of life on Earth. And the video before this one you'll see concerning the Clovis culture, the Younger Dryas impact. The comet was in various fragments, about 4 kilometers long, and that was an extinction level event for the Clovis culture, megafauna as well. So yes, of course it could have altering evolution of life on Earth, particularly when the underlying terrestrial material at the impact site contains large amounts of carbonates and sulfates. The dating of certain large impact craters, 50 kilometers and greater, found on Earth have matched events such as the extinction of the dinosaurs. We know that happened about 66 million years ago. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. Ironically, one could argue that humanity owes its emergence in part to the impactor that killed the dinosaurs. Can you imagine if we existed with them? Now, only rather recently did scientists begin to widely acknowledge that sizable impactors from space strike Earth. It was extremely important, in fact, that first intellectual step to recognize that, yes, indeed, very large objects do fall out of the sky and make holes on the ground, said Eugene Shoemaker. Shoemaker was a co-discoverer of the Shoemaker-Levy 9, which was a fragmented comet that hit Jupiter in 1994. Hildebrand in 1993 noted that the hypothesis that catastrophic impacts cause mass extinctions has been unpopular with many geologists. Some geologists still regard the existence of 140 known impact craters on Earth as unproven, despite compelling evidence to the contrary. Now, beyond the asteroid that struck Mexico 66 million years ago, that was a dinosaur extinction event, and helped end the reign of the dinosaurs, there are numerous lesser-known terrestrial impactors that also appear destructive given their size. For example, at least 3 sizable impactors struck Earth 35 million years ago, one of which left a 90-kilometer crater in Siberia, the location of Popigai. At least 2 large impactors occurred near the Jurassic-Cretaceous boundary, the Moroweng and Mjolnir, and the latter may have been the cataclysm for a tsunami that dwarfed the recent event in Japan. And now, Glimsdale et al. In 2007 wrote, "It is clear that both the geological consequences and the tsunami of an impact of a large asteroid are orders of magnitude larger than those of even the largest earthquakes recorded, of course." However, in the CNN interview, Neil deGrasse Tyson remarks that we'll presumably identify the larger impactors ahead of time, giving humanity the opportunity to enact a plan to hopefully deal with the matter. In other words, he's saying that get this thing out of the way so it doesn't impact us. But we have no way of doing that today. So yet he added that often we're unable to identify smaller objects in advance, and that is, of course, problematic. The meteor that exploded over the Urals a little while ago, the Tunguska, the Chelyabinsk event, is an example that we didn't see it. Now, in recent human history, the Tunguska event of 1908 and the asteroid that recently exploded over Chelyabinsk are reminders of the havoc that even smaller size objects can cause. The Tunguska event is presumed to be a meteor that exploded in 1908 over a remote forested area in Siberia and was sufficiently powerful to topple millions of trees. Had the event occurred over a city, it may have caused numerous fatalities. Mark Boslow, scientist who studied Tunguska, noted that such a small object can do this kind of destruction suggests that smaller asteroids are something to consider. Such collisions are not as improbable as we believe. We should be making more efforts at detecting the smaller ones than we have until now. Neil deGrasse Tyson hinted that humanity was rather lucky that the recent Russian fireball exploded about 20 miles up in the atmosphere, as its energy content was about 30 times larger than that in the Hiroshima explosion. It should be noted that the potential negative outcome from smaller impactors increases in concert with the increased human population. So how often do large bodies strike Earth? And is the next catastrophic impactor imminent? Do such events happen on a periodic basis? Scientists have been debating those questions, and no consensus has emerged. Certain researchers advocate that large impactors, leaving craters greater than 35 kilometers, strike Earth with a periodicity approximately 26 to 35 million years. The putative periodically, hence the Shiva hypothesis, is often linked to the sun's vertical oscillations through the plane of the Milky Way as it revolves around the galaxy. Although that scenario is likewise debated, as many of the assertions put forth in this article, the sun's motion through the denser part of the galactic plane is believed to trigger a comet shower from the Oort cloud. The Oort cloud is theorized to be a halo of loosely bound comets that encompasses the periphery of the solar system. Essentially, there exists a main belt of asteroids between Mars and Jupiter, a belt of comets and icy bodies located beyond Neptune called the Kuiper Belt, and then there is the Oort cloud, a lower mass companion to the Sun, which is likewise considered as a perturbing source of Oort cloud comets. That's the Nemesis affair by D. Rope. The aforementioned theory pertains principally to periodic comet showers. However, that mechanism can explain how asteroids exit their otherwise benign orbits in the belt and enter the inner solar system as Earth crossers, which is very dangerous, of course. One potential stochastic scenario is that asteroids are ejected from the belt via interactions with the planets through orbital resonances. Evidence for that scenario is present in the images, showing that regions in the belt coincide with certain resonances are nearly depleted of asteroids. A similar trend is seen in the distribution of icy bodies in the Kuiper Belt, where Neptune, rather than, say, Mars or Jupiter, may be the principal scattering body. Note that even asteroids and comets, not initially near a resonance, can migrate to one by various means, hence the Yarkovsky effect. When the sun heats the part of the asteroid or comet, makes it topple from its trajectory, changing course. So if an asteroid in the belt were to break up, hence a collision, near a resonance, it would send numerous projectiles streaming to the inner solar system, where we are. And that may help partly explain the potential presence of asteroid showers, the Bol, Tish, and Chicxulub Yucatan craters both date to near 66 million years ago. In 2007, a team argued that the asteroid, which helped end the reign of the dinosaurs, entered an Earth-crossing orbit via resonances. Furthermore, they noted that asteroid 298 Baptistina is a fragment of that dinosaur exterminator, and it can be viewed in the present orbiting 2 AUs from the Sun. So it's still around us, God forbid. The team's specific assertions are being debated, however, perhaps more importantly, the underlying transport mechanism that delivers asteroids from the belt into Earth-crossing orbits appears well supported by the evidence. So it appears that the terrestrial impact record may be tied to periodic and random phenomena, and comet asteroid showers can stem from both. However, reconstructing that terrestrial impact record is rather difficult, as Earth is geologically active by comparison to the present Moon, where craters from the past are typically well preserved. Thus, smaller and older impactors are undersampled. The impact record is also incomplete, since a sizable fraction of impactors strike the ocean, so we can't see what's in the ocean, of course. Nevertheless, an estimated frequency curve for terrestrial impacts, as deduced by Rampino and Haggerty in 1996, is reproduced. We note that there is considerable uncertainty in such determinations, and the y-axis in the figure highlights the typical impact interval. So in sum, as noted by Eugene Shoemaker, large objects do indeed fall out of the sky and cause damage. It's unclear when in the near or distant future humanity will be forced to rise to the challenge and counter an incoming larger impactor, or again deal with the consequences of a smaller impactor that went undetected and caused human injuries. The estimated probabilities are not reassuring given their uncertainty and what's in jeopardy. Humanity's technological progress and scientific research must continue unabated and even accelerated, thereby affording us the tools to better tackle the described situation when it arises. In discussion of the topic, fear-mongering and alarmist in nature, the answer should be obvious given the fireball explosion that happened recently over the Ural Mountains, the Tunguska event, and past impactors. Given the stakes, excessive vigilance is, of course, warranted. Now, the interested reader desiring additional information will find following pertinent: the Earth Impact Database, Hildebrand 1993, Rampino and Haggerty 1996, Stothers 2006, and others as are mentioned here in the article. And this is by Universe Today on phys.org by Dan Mayes. Please leave your comments. Thank you for your support.